Hi math lovers, welcome to notes number 64, lesson 3.4, zeros of polynomial functions. And this is the first day of this. Before we get started writing down our notes, I want you to go to your book, page 303, numbers 9 through 14. We're going to do those together. Let me grab my book for us, put that right on the camera, make sure I got it zoomed in for you so you can see it. Nice and clear. There we go. Okay, so let's take a look at each of these problems. The first one says find the zeros of the function. So I'm taking a look of f of x times x minus 6, the quantity squared. So my roots here for number 9, my roots here are going to be 0 and 6. And remember, that 6 is a special 6, isn't it? That 6 is a double root. Double root. It means it's going to bounce. It's going to hit that x-axis and it's going to bounce and turn. Taking a look at number 10, I've got x squared times x plus 3 times x squared minus 1. Okay, so I'm thinking about all of my roots. So let's see, this first one would be 0. 0 is a double root, right? Ooh, double root. Put a little arrow to it. It's double root. I have negative 3. That would make this factor equal 0. And this one, well, that would be a plus or minus 1. Now that makes sense that I could have that many roots. Notice that I've got a power of 2, 3, 4, 5. So I've got 2 zeros here, 3, and this is a double root, 4, 5. Number 11, I'm looking at my roots for number 11. I've got a 2 and a plus 4. So we've got 2 and negative 4. Number 12, so forth and so on. It's the same thing. Notice in number 12, we're going to have a double root. We've got to think about that. 8 is a double root. Negative 5 and 8, of course, is a double root. And then we get to 13, and we introduce an imaginary number in 13. This is going to be very different for us. Let me move this up so you all can see it. Make it nice and crystal clear. There we go. Okay, so looking at number 13, I have roots 6, negative 6. And to make these 0, it would be imaginary. So that would be plus or minus I, okay? 14, we're not going to graph that. 14, look at what you have. Well, you've got a positive 3, a positive 2, and then plus or minus 3i. Okay? If I FOILed this all out, notice that all my terms would be rational. I would not be left with any, they'd be real. I wouldn't be left with any imaginary numbers. Okay? So let's go out of your book now and let's try a new theorem. This new theorem is called the rational root theorem. And the rational root theorem says that, oops, I'm all caught up here. Sorry about this, friends. May feel like a little seasick here as I shake the table. All right, it's safe to look back up again, okay? The rational root test will allow us to figure out what our roots are going to be. So we're going to take the factors of a constant term, which is our last term, and divide it by the factors of our leading coefficient. So I've got an example for us, number 17, I pulled out of your textbook, and we're thinking about the function f of x is equal to 2x to the 4th minus 17x cubed plus 35x squared plus 9x minus 45. I wanted a problem that you could not factor, all right? I was trying to think of one that you could not factor. So let's find all our possible rational roots. Remember, rational means you can write it as a fraction. All right? So let's see. All the factors of the constant term. So think about the factors of 45. 45. Oh, plus or minus, right? Plus or minus 9. Plus or minus 5. I'm going down in descending order. Plus or minus 3. Plus or minus 15. Oops, out of order there. And plus or minus 1. And I'm going to divide each of those numbers by the factors of the leading coefficient. Well, what are my leading coefficient factors here? Oh, 2. Oh, so I could have a 2 here, and under each of these, you know what else I could have? Yeah, I could have a denominator of 1. So I should use those same numbers again for my numerator and make them all over 1. Now, you have a lot of factors here, don't you? Oh my goodness. These are all the possibilities. What you would do is you would take all of these numbers and you would use your synthetic division and figure out which one had a remainder of 0, okay? Now, this would take you forever. What I prefer to do, instead of taking forever to figure out what my rational roots are, is I like to go to the graph, okay? So go to your graph on your calculator, and you're going to go ahead and you're going to make that graph. And the graph, oh gosh, if I can sketch it, is going to look something like, goes down like this, and then it comes back up. It goes through here, something like that. And I end up using my table feature to look to see, there's a button that says table over to the right on your TI-84 to see exactly what those roots are, okay? And you'll see that your possibilities for here, your zeros, are -1, 3/2, 3, and 5, okay? And so are those in our list? Yes, yes they are. And if I did long division with those zeros, I would have a remainder of 0, okay? Let's try another one. This time I'm going to introduce some imaginary numbers into our problem. All right, so if I'm going to pull number 47 from our book, and this time they're going to tell me what the roots are. It says that I have real coefficients. That's important. And I have the roots 2 and 5 minus I. Now, if I have real coefficients, all right, if I have real coefficients, that means that I must have another one to complement this 5 minus I. That means I have to have 5 plus I as well. Because when I multiply the two together, it's going to give me a real number. The imaginary is going to disappear. Oh, this is going to be so much fun. Here we go. F of x is equal to the first root. So that's x minus 2. My second root, x minus parenthesis 5 minus I. Be real careful with those parentheses, kids. Okay? And then 5 plus I. Okay, here we go. Now, I'm not convinced that this is going to be real. I'm not convinced that they're real coefficients. So I'm going to focus right here on this part of the problem. I'm going to bring my x minus 2 down along with me. Before I can start to FOIL, I'm going to distribute the minuses. I'm terrible with minuses. I lose the signs all the time. So x minus 5 plus I times the quantity x minus 5 minus I. Now stop for a second and look where I put the minuses. The minus here, right, the subtraction sign in each of these, it divides the variable and the root, okay? You see that? Notice that I have changed the sign for the conjugate, what's inside the parentheses. That's what has changed, all right? So here I go. I'm going to multiply these two together, and you know how I like to multiply using my Punnett square. So I'm a messy person, and I like to keep things neat. Maybe if you're new to my class, maybe you didn't know this, but I am a messy person. And if I can keep it all neat with my Punnett square, I'm good to go, okay? So wait, I think I lost a sign, didn't I? It's a minus I. Hold on. I need to have a minus right here. Sorry about that, okay? So I go ahead and I multiply. See how easy it is to lose a minus sign? I haven't even started multiplying and I've lost the minus sign. Be careful, kiddies. Be careful. So let's see, I'm moving right along, I squared. Now we know, oh, this is beautiful. Let me grab a pencil here. We know that these are going to fall out. Pachoo, pachoo. And I've got these terms here, I add them together, and they're going to fall out. And I know this I squared, I know what I squared is. I squared is -1, isn't it? So it's the opposite of -1, so that's just going to be 1. So when I simplify this whole mess, when I simplify this whole beautiful problem, I'm going to be left with x squared minus 10x plus 26. Okay? Now, for me, that's where you could stop. Okay? For me, we could write our final answer as f of x is equal to some coefficient a. Let's use it as our placeholder because we don't have any more information about our problem. All right, so for me, this is where I would stop, okay? That's enough for me. Ron, our author, likes to go a step further, and he likes you to take this whole problem and FOIL it out to f of x is equal to a times the quantity, x cubed minus 12x squared plus 46x minus 52. Now, this is where he's going to go, all right? For me, you have convinced me that the imaginary numbers are gone here. So either of these answers are acceptable, all right? Once you've multiplied it all out, that's good enough for me. If you're using CalChat and checking with our textbook, you need to go that extra step and FOIL the whole thing out to make sure you have the right answer. Don't be freaked out when you see the answers there, all right? So today we talked about writing all the possible rational roots of our problems. And we thought about, what if our roots were imaginary, right? How would we write them? How would we convince our reader that we have real coefficients there? Have fun with your problem set.